Everybody. So I suggest people sit one desk behind because I have a running nose today, and if I accidentally sneeze, it will be like okay, just one desk behind. Just take one desk behind everybody. Or the first bench can go to the last bench, whatever. This is small class. Everybody mask on today. So I have alerted all of you. Now it's your responsibility. Okay. So in the last class we finished the last chapter, right? Which was sound. We completed it. Did we do numericals in sound? Huh? We completed. 5 numericals we did. So rest you can do like it's not. So we can start with electricity today. Okay, very good. So we'll be starting with chapter number 8, which is electricity. Current electricity. So in this chapter, what are the topics here? We have concept of charge, then electric current, right? Then we have electric potential, then potential difference, potential difference. This is at a point this is between 2 points. Okay. Then we have concept of resistance. Let's see how much we are able to cover here. Ohm's law. And resistivity. Okay. So let us start. So what is charge? What is charge? 4 of you on the same bench. Why is it so? Okay, you're comfortable, all 4 of you. Okay. So the symbol of charge is Q. Anybody? What is a charge? So it is observed, okay? What is observed? That when certain bodies are rubbed against each other, they develop attractive property. Like if you take out a scale, anybody has scale? And make small pieces of paper, rough paper, like ticket or cinema ticket. जो thermal paper होता है, किसी के पास है क्या? Small piece of paper.
Charge the force by which electrons move.
I will tell you what it is. हाँ छोटा उसके छोटे एकदम छोटे. Make very small pieces of paper or give it to me. No, somebody come and do it. I can't touch it. Come here. We'll demonstrate it for the whole class. Parents off or something. ये सबने किया होगा पहले वहाँ पे छोटे पीसेस करो back towards that wall come like this see I saved you और छोटे बस 4 काफी ये जो किया ना उसका और छोटे बाल में तेल नहीं होना चाहिए ड्राई है बस बेटा बस तोड़ मत अरे चार्ज नहीं इधर ऐसे कैसे और छोटे कैन somebody try some other scale नहीं फिर से उसी हेल्प में करेगा क्या देखो हाथ नीचे रखो तोड़ मत देना स्केल रब इट अरे बाल तो स्किन पे नहीं बाल के ऊपर हाँ यू नॉट नोइंग हाउ टू डू इट ऐसे नहीं करना है यार कैन आई टेक एनीबॉडी स्केल यू मेक स्मॉल पीसेस यहाँ रखना अंदर यहाँ ले जाओ छोटे करो प्लीज इसमें 4 टुकड़े करो Now give me one scale. What is it doesn't? सब लोग it could be a microsecond so everybody concentrate. थोड़ा हटो अरे बहुत बड़ा है यार ये हिली क्या यस चल रहा है दूसरा स्केल स्केल में प्रॉब्लम है बहुत ये कभी किसी ने देखा है
सर बचपन में तेल रहता था तब होता सर पेंसिल के साथ
अरे बिल्कुल भी कुछ नहीं हो रहा है इसके अंदर इसलिए मैं थर्मल पेपर छोड़ो जाने दो करके देखना घर में और हैव यू सीन इन ड्राइंग व्हेन यू कॉम हो रहा है ना
के साथ ज्यादा
boys one of you do it man it's like you know you're losing practice हुआ ना ठीक है चलो मतलब होता है समथिंग मतलब कुछ ऐसा होना चाहिए हाँ दिखाओ नहीं हो रहा है हल्का सा ठीक है नाउ यू जो था ना स्केल को ऐसे हाथ से ऐसे कर दो हाथ से सो जो अब करो पेपर के ऊपर हो रहा है अब नहीं हो रहा है सो द चार्ज इज गॉन सी व्हाट हैपेंस इज तो जब तुमने रबिंग किया तो क्या हुआ देखो इट इज ऑब्जर्व when certain bodies are rubbed with each other, right? When certain bodies are rubbed with each other, it develops attractive properties. ठीक है जैसे अभी हमने स्केल को रब किया and it developed attractive property, right? then we say the bodies are charged. Okay? When it develops the attractive property, right? Then we say that the bodies are electrically charged. Okay? So what happened during rubbing, right? During rubbing process, one of the body loses electron, okay? Loses electrons, like many electrons, right? And the other gains it. Other gains it. Okay? So the body which loses electron is called negatively charged. Oh, sorry, positively charged. So there are three things that you have to. The body that loses electrons is said to be positively charged. Okay? And body which gains electron is said to be negatively charged. Okay? Why it is so? Now see the example. Like this is scale, or this is a glass rod, for example, a glass rod. And we have a piece of silk cloth. Okay, this is silk cloth. So when glass rod is rubbed on silk cloth, what happens? See, initially it will have equal amount of positive and negative charges. Because any substance is electrically neutral. So it has equal number of positive and negative charges. Here also. So it has so what is the net charge? Zero. है ना? इसके भी zero है, इसके भी zero. अब जब हमने इसको रब किया, so it will go here. Let's say it lost some electrons. इधर गया. Negative electron has a negative charge, right? So now what happens? So this goes here and it neutralizes it. Okay? So here now there is no balancing, so there is a net positive charge, excess of positive charge here. Okay, na? So this becomes positively charged. Right? So during rubbing, and now what has happened? These positive charge have been neutralized. So now there are three positive charge, but there are three excess electrons, so it has excess negative charge. So this is now negatively charged. So now the bodies have excess charge on them. Here excess positive, here excess negative. You understood what is positively charged and what is negatively charged? And how the charge came? This process, this rubbing process is called charging process. So how did we charge it? We did work on it. So we spent mechanical energy that got converted into electrical energy. Okay? So energy we only spent. That energy is now appearing as electrical energy. Got it? So likewise, here we mechanically charge the body. In electric cell, what do you have in electric cell? You have electrodes. So this is copper and this is zinc. Okay? And then you have an electrolyte. So this is dilute H2SO4. So it will react with copper. Then copper loses electrons. So it will become positively charged. The copper electron. So the electron came here. Excuse me. Now it gets deposited on zinc, again through chemical reaction. So this becomes negatively charged. So you have a cell. So this process continues till equilibrium stage is reached. Okay? So this will become positively charged and this will become negatively charged. So cell always will have this difference in the electric charges on its terminal. So these electrodes are called terminal nodes. Electrodes or terminals of cell. So this is the schematic diagram of electric cell. Cell diagram. Okay, and this is the symbol which we'll be using. So now you understand. So cell terminal, there is a difference in the nature of charges which are deposited. Okay. So this difference is denoted by a letter V, which is called potential difference. Okay. So the difference in the charges over the terminal of the cell is called potential difference. So positive is called high potential. And negative is called low potential. So when you buy a new cell from the market, so it will have full potential, means full charge on it. Now when you start using the cell by lighting a bulb, slowly all the charges will get discharged over long usage. Okay? So then you have to replace the cell, right? So basically what happens, when this charge will come from here and neutralize it, there is this chemical reaction. It will again rebuild the charge. So here who is working for charging? It is the chemical energy is getting converted into electrical energy. So there are so many ways in which electrical energy can be produced. In the first case, we use mechanical to electrical. Here, chemical is creating these charges. No? So it is who is working? The chemical reaction or the chemical energy. Got it? So every reaction has a lifetime. You have either learned in chemistry or you will learn about it. So as long as, so whenever this external switch is made on, this charge will go from here and it will get neutralized. Then the chemical reaction will again supply the charge. So it will balance the potential difference. Got it? So as long as this electrolyte, so this electrolyte has strength. Okay? So the cell will be useful. But over long usage, the chemical reaction will reach its lifetime and cell will have to be replaced. Okay? So ये हम दिन भर तो नहीं कर सकते ना, जितना देर चार्ज करेंगे बस उतना ही यूज कर सकते हैं, उसके बाद नहीं. Got it? So it is the same thing. All right. So first write all these concepts, then I'll discuss again. So this is a concept. Huh? If it is clear, that will go further in charge. This concept will be useful further. Have you written everything? Right now. ये डायग्राम नहीं बनाया, यही तो बनाना है, कॉन्सेप्ट डायग्राम. This is for understanding. Huh? So electric cell में what is happening in electric cell? In electric cell, what happens? The chemical energy is getting converted into electrical energy. Why are we saying so? Because now it will start making the objects move. Switch on the fan. Can I erase this part? Mid column?
Yes.
Now let's understand what is unit observer. Capital C, right? So charge on electron is minus E. Okay. So when I write E minus, it is electron. And what is the charge? Minus E. It is equal to minus 1.6 into 10 raised to minus 19. क्या नहीं आ रहा है समझ में बोलो? Which word? Electrode. Terminals. Electrodes or terminals. So this is for the upper one. This is positively charged because it is now these electrons are lost. So X is positive. Whenever the body has charge imbalance, then we say the body is charged. So देखो, how the charge is building up on a body, electron by electron. So the charge will increase or decrease minimum by this amount, not fraction of it. Got it? Charge on a body, minimum charge is this much. It will increase in the same addition. Okay, not fraction of it. So therefore, charge is always given as plus minus NE, where not plus minus, charge is given as NE, where N is equal to plus minus 1, 2, plus minus 3, like that. You will never have 1.5 or 1.3, ऐसा नहीं आएगा. 1, 2, 3 integral multiples. ठीक है? That is, charge is added or subtracted. In integral multiples of E. और E क्या है? This value. So इलेक्ट्रॉन पे चार्ज ये है, प्रोटॉन पे कितना होगा? सेम बट प्लस, ठीक है? प्रोटॉन पे क्या होगा? प्लस 1.6, so it will be plus E. Okay? Symbol for 1.6 into 10 raised to minus 19 coulomb is E. All right. So this completes our discussion on charge. Next is electric current. I. The symbol for electric current is I. How do we define electric current? It is the rate of flow of charge through a conductor. Right? It is defined as rate of flow of charge across the cross section of the electric conductor. ठीक है? Now what is electric conductor?
A material which freely allows electricity to pass.
Correct, very good. Conductor is any substance which allows flow of electrons, flow of charge, free flow of charge, which is electron, through it. ठीक है? So this is a conductor. So any examples of conductor?
Metals.
All metals, right? Most of the metals are good conductors of electricity. So substance which has a lot of free electrons will be a good conductor. Erase it completely?
Yes.
There's no ink. So, examples of good conductors are, you have copper, you have silver, aluminum, okay, so on and so forth. All metals are good conductors. Any bad conductors?
Good.
Human. Are also conductors. So don't put your finger in socket, okay? Alright. So bad conductor examples?
Good.
Yes.
Plastic.
These are also called as insulators. Okay? So rubber, plastic, human and earth also. Okay, electricity passes in earth very quickly. Rubber, plastic, glass, pure water, right? Pure glass, so on and so on. So dry air. These are all insulators. Dry air, not humid air. Okay. So it is defined as rate of flow of charge across the cross section of. So what is the formula? That is I is equal to Q by T. Rate of flow of charge, मतलब how much charge is flown across the conductor. So suppose this is the conductor, right? This is the cross section. So let us say electrons are flowing in this direction. So what is the amount of charge flown in unit time across the cross section? That is the current flow. Let's say this is I. So will I be in the same direction as flow of electron? No. Current direction is always taken opposite to the direction of flow of electron by convention. Okay. So conventionally, the direction of current I is taken opposite to the direction of flow of electrons. Hence, it is called conventional current. Conventional current. Now, if I take a piece of conductor, will current start flowing in it on its own? No. What should we do? We should attach a cell, right? Like this. Okay. So this is negative terminal. So it will what it will do? You know that like charges repel each other and unlike charges attract each other. In the charge discussion, you add one note. Like charges repel each other. Huh? Sorry? That is this one. This one. Yeah, this is the enlarged part of the same wire. Okay? So, and this is conductor. This is all of it is conductor only. This is magnified for your understanding, right? Conductor. So wire is generally cylindrical, right? So this is magnified. So what is happening? I told you. So let us say it has a potential difference, right? So this has excess of electron. So all the electrons it will push away. So the electrons will start moving in this direction, right? And what do we say? So electrons will start moving in this direction. So we say current is moving in this direction. Okay, understood? So the direction of current is from high potential to low potential outside the circuit, outside the cell. Got it? So why have we taken conventional current? Because in real life, always bodies fall through high level to low level. Water will always flow from high to low. You never see water flowing down to up on its own. Okay? So here, what is seen? The charge is flowing from low potential to high. Current is because of charge flow only. But now, the way we interpret is, we say the current, conventional current, therefore is flowing from high to low to match it with the natural phenomena. Is it clear? Because here it is happening opposite. The electron is flowing from low potential to high potential. Right? So we say by convention, the electric current is flowing from high to low. That's what we say. To match it with other natural phenomena. Is it clear? Okay. So just remember it. So now in some questions, because Q is equal to NE, you can also write I is equal to NE upon T. Can you do that? Because Q is equal to N times V. Okay, so you can do that also. Now what is unit of current? Unit of current is ampere. Okay. So what is therefore what is 1 ampere? 1 coulomb upon 1 second. Okay. So when 1 coulomb of charge passes through the cross section in 1 second, we say that the current is 1 ampere. ठीक है? मतलब ये जो सर्कल दिख रहा है, when you cut it through that circle, 1 coulomb charge is passed in 1 second. Then we say the current is 1 ampere. Got it? Okay. So we completed electric current. So anybody has any questions till here? Now, we said, is current having any charge on it? A piece of conductor, does it have any charge on it initially? No. Net charge is 0. So, therefore, every electron should have a associated positive charge, correct? Because if it is, let us say, copper wire, okay? So, there will be copper atoms which will be, so when the the electron leaves the atom, that atom becomes positive core, okay? So in a conductor, only electron is moving, not the positive core. Okay? So whenever the electron moves, it collides with, so it's not a free flow. Collide kar karke jata hai. So that is why the motion of the electron is obstructed. And that is called resistance. The measure of obstruction is resistance, right? So before that, let's now understand what is a potential. So right now we just make this positive ions. I'll explain it further when we discuss resistance. Okay. Can I hear the pedal corner? You still have 20 minutes, right? Are you done writing that?
Yes.
Now let's define what is electric potential. Okay. I want you all to be completely free. First, finish writing, then only I'll start this. Okay. So let's begin. Suppose we have an electric charge over here. So this we are calling source charge. Right. So there is some reason around this charge. Now let us say at a far away distance, which we are calling infinity. This point is, there is this point P, which is at infinity. Okay. We are now bringing one charge from here to here. This point, let us say. This point is close to a positive charge. What kind of charge is Q? Positive charge. What kind of charge is small q? That is also positive charge, but it's a small charge. So when I'm bringing a small positive charge near a bigger positive charge, will I have to do some work? No. Will it not repel it? Huh? So it's like I'm trying to compress a spring. Imagine this is a relaxed spring in mechanical scenario. When I press the other end of the spring, I have to do work, right? So whatever work I do, that will be stored in it as its elastic potential energy. So here, whatever work I am doing, okay, let's say I do the work W in bringing this charge from here to here. Okay, so whatever is the work done against this force of repulsion, that work is stored into it as its electrical potential energy at this point. Okay, whose electric potential energy? Q. Got it? So we call what is the electric potential then? It is the work done in bringing a unit positive charge. So let's say we were bringing unit positive charge from here to here. Whatever work is done in that, we call that potential at point E. Understood? So it is the work done, right? So electric potential at a point, electric potential at a point near a positive source charge is defined as the work done in bringing a unit positive charge from infinity to that point against the electric repulsion, electric repulsive force against its point near a positive source of is defined as a work that is included against force of source. Is this understood? Whatever source of the and use the spring analogy. So somebody is doing the work in bringing the charge. So in cell, who is doing that work? The chemical reaction. It is going on depositing negative charge on the zinc electrode. So already negative charges are there, but it is going on depositing more against the repulsion. So it is due to chemical reaction. So it is the chemical energy which is doing that work. Who does the work? Always the energy. If I am to bring this charge, then I am spending mechanical energy. But generally, charges are in millions and billions. So I am not doing that. So it is the chemical energy which is automatically doing that. Okay? Understood? So this is how we define the potential at a point P. Right? So if W is the work done in bringing charge Q from here to here, what is the work done in bringing unit positive charge? W by Q, unit difference. Right? So therefore, V is equal to W by Q. Isn't it? Work done per unit charge. Irreversible. Is it clear? If W is the work done in bringing charge Q from infinity to point P, then what is the work done in bringing unit charge from infinity to this point? W by Q. Unitary method. That itself is electric potential at point P. Okay? So unit of electric potential is volt. Right? SI unit is volt. Therefore, 1 volt, and the symbol is V. The नाम है scientist का voltage, right? So उससे volt आ गया. So 1 volt is equal to 1 joule by 1 second, or 1 coulomb. This is how you define 1 volt. Okay, so that is electric potential at a point. Now we will see what is the potential difference. Potential difference This is also V between 2 points. अब हमको पोटेंशियल डिफरेंस डिफाइन करना है. So फिर से हम एक सोर्स चार्ज ले लेते हैं. Now let us say the 2 points are P and Q. ये हमारा इंफिनिटी है. Are you done writing? तो आप देखो. Let's say the work done in bringing the charge Q from infinity to point Q is WP. Okay? And the work done in bringing the charge from infinity to Q is WQ. ठीक है? So the excess work done in bringing the charge from Q to P will be WP minus WQ. Correct? So what is this work done? Potential difference between 2 points P and Q is nothing but the work done in bringing the charge from Q to P. Isn't it? So therefore, work done. So this will be what? WP minus WQ. Isn't it? So this is the potential difference, right? So potential difference between points P and Q is equal to work done in bringing unit positive charge from Q to P. Okay? Right. Now work done in bringing Q was WP here, and work done in bringing Q small q over here was WQ. Okay? So what is potential at P? Potential at P was VP, and potential at Q was VQ. What is it? Instead of plus Q, when we are bringing unit positive charge, then the same work done we are calling as VQ, and here we are calling that as VP, right? So what is potential difference between point P and Q? Obviously, which work is more? VP, that is VP minus VQ. But what is VP? It's nothing but WP upon Q minus WQ upon Q, isn't it? By the definition of potential. So we have just written respective points. The charge is Q, right? So this VP minus VQ we are calling as V. And this will be WP minus WQ by Q, taking common denominator. And now WP minus WQ is the work done. This we are calling the work done. Understood? So here, where V is the potential difference between point P and Q. And W is WP minus WQ. It is the work done in bringing the charge from Q to P. So essentially, the formula for potential difference and potential comes to be same thing. Here, potential is when you are bringing the charge from infinity to that point. And difference is you are bringing the charge from Q to between 2 points. So this is a more practical thing. Because in practice, we use cell in circuit, where we know both the points, where it is. We never bring infinity. So we have used this concept to basically define what is electric potential. And then this is a more practical thing which we use. So potential difference, it is this which is used more. Okay? So if you have any questions till here, you can ask me.
So P and Q are any points on the circuit, right?
Any points, any 2 points. Okay. Near the source charge. Like in cell situation, you have terminal. So उस पे charge लेके आ रहे हैं, बार-बार you are depositing, right? So when you are depositing, somebody is doing work. Like chemical reaction is doing work. Chemical energy getting converted into electrical energy. So that way. So let's say this is the terminal of the battery, and this is the point near. Okay. So to answer your question, these 2 points could be at any 2 points between the conductor. Any 2 points. So to move the electron, you have to do work. So who is doing that work? Cell. Okay. It will become more clear as we go forward. Has this chapter been taught in your schools?
No.
No?
Yes.
Yes.
For you it is done?
Yes.
So was this concept clear?
Yes.
Is it now better?
Yeah.
Okay. Anybody has any doubt, please ask. We still have some few minutes. Today no new topic, we'll stop here. So we did electric potential. Not bad. In the next class we'll go through. So what is 1 volt? How will you define 1 volt? Here. When do we say that the potential difference between 2 points is 1 volt? When will we say that? Raise your hand if you want to answer.
Can you repeat the question?
What is, when do we say that the potential difference between 2 points is 1 volt? It's on the board. Yeah.
When work done per unit charge from to bring electrons from one point to the other.
You're saying unit charge when you're saying electron. Sorry. What is the unit charge on electron?
Unit charge is 1 point minus.
It's minus, so. Unit positive. Is the charge on electron 1 coulomb?
Solar electron.
What is the charge on electron?
Minus 1.6 into 10 to the power minus.
Minus, it is so small. It's not 1 coulomb. When is the potential difference? So potential difference between the point P and Q is 1 volt, right? When in bringing 1 coulomb charge from here to here is, what is the work done? 1 joule. Okay? Here I have already written. Sorry. The definition is written. Same definition will be written there. What is potential difference 1 volt? When 1 joule of work is done, bring unit positive charge from Q to P now. That, and you are doing only 1 joule of work. Then we will say potential difference between P and Q is 1 volt. So you don't have to memorize, it's just written here. These are the 2 points. You are spending 1 joule in bringing 1 coulomb between those 2 points. When that is the case, the potential difference between those 2 points is 1 volt. Okay? Alright. I think we have a class tomorrow as well. So read this and come, okay? Then it will be good. Alright, see you.
Thank you.
Thank you.